Hello everyone, welcoming you to another video on advanced game theory. And as I had mentioned, in this video we are going to start off with a real life example of a cooperative game theory. And this is a very famous example, which is a landlord tenant game. I've just mentioned briefly that what the structure of the game is all about. And after we have understood the game, then we'll actually write out formally the this setup in a cooperative game format, and then we will illustrate that how actually we can find out a core of a cooperative game. So situation of the game is something like this. Point number one is that we consider a landlord who has a plot of land and he needs tenants to cultivate the land to generate any profits, because the landlord will not cultivate the land himself. So suppose for this purpose we have two tenants from which he can select. The landlord knows that if he hires any one of them, then he gets a profit of 100, and if the landlord hires both the tenants, then he will get a profit of rupees 150. And if the landlord doesn't hire any tenant, that means he's alone, then he can create no profit because he's not working on the land. And finally the last point, that neither of the tenants, whether they're alone or together, can generate any profit because they do not have any land to work on. So how can they generate profit? Now another crucial thing over here that I want to mention, if it's not very clear from the write-up that I've given over here, is that in points 3 and point 4, let's say I'm talking of point number 3, that if the landlord hires any one of the agent, he gets a profit of 100. Now this profit has come out because landlord and one agent have decided to cooperate. Although you can say that okay, the tenant is only working, but the landlord has ownership claims, right, on the land. So this landlord and the tenant coming together and cooperating together have produced this rupees 100. So this is the joint output, that is a joint profit that is produced when a landlord decides to is cooperated by any one of the tenants. So how can we first of all write it out in a structure of a game? So let me first write, let's say we have, so over here obviously we have a setup where we have three people. One is a landlord and there are two tenants. So I have a 3-player structure where my A1 is, say, landlord, A2 is, let's say, he's the first tenant, A3 is the, let's say, the second tenant. Okay, alright. So now from all these information, let us understand the worth of all possible coalitions. So you can understand that coming to the fifth point, if the landlord is alone, he can't generate any profit. That means worth of A1 alone is equals to 0. Neither of the tenants alone or together can generate any profit. So if A2 is alone, then also the worth is 0. If A3 is alone, then also the worth is 0. But when A1 and A2 are together, that means the landlord decides to cooperate with any one of the tenants, then there is profit of 100. If the landlord, which is A1, decides to cooperate with the other tenant, then also the profit is 100. But if the two tenants are together, A2 and A3, then there is 0 because there is no worth. And finally, when the landlord hires both the tenants, that means V of A1, A2, A3, which is essentially Vn, is 150. And by definition, for completeness, V of empty set is 5. So this is essentially the game that we are talking about, and we are essentially interested in obtaining the core of this game. We want to find the core of this game. This is what we want to do. Now actually, let us first write out the set of imputations so that it's easier for us to understand. Now what will be the set of so what essentially we have 3 players, right? So how is a payoff vector defined? A payoff vector is X and it has 3 components because there are 3 players. X of A1, X of A2, X of A3. Okay? And what is the set of imputations? It is the set of all payoff vectors such that it is individually rational. So xai is greater than equals to 0 in this case, right? Because from the first point, what do we understand? That V of ai is equals to 0 for all players, right? and xn should be equals to vn. If you so xn should be equals to vn. Vn over here is 150, right? So this is what we have. And what is essentially the core? It is basically a set of all payoff vectors which belong to the set of imputations such that xs should be greater than equals to vs for all s which is a subset of n, and s should not be equals to phi. Correct? This is what it is. So now our job is to find out the core. Now you can understand that for a particular payoff vector x to belong to the IV, what are the conditions that needs to be satisfied? X of a1 should be greater equals to 0, x of a2 should be greater equals to 0, x of a3 should be greater equals to 0. This is equation number 1. This condition has to be satisfied, right? Then it has to be Pareto efficient. That means Pareto optimal. So sum of the payoffs, that means x of a1 plus x of a2 plus x of a3 should be equals to 150. These are the two conditions that we directly get from imputations. And now over and above these two, we have a third condition to address for core, which is the xs greater equals to vs. Therefore, for a particular payoff vector to be in the core, along with these two, you will have to satisfy these things. Now, what can be the possible coalitions? Now, note one thing: the singleton coalitions have already been taken care by individual rationality, and the grand coalition issue has already been addressed by the Pareto optimality. So, we only need to consider the strict subset coalitions. So, what are the possibilities? X a1. So, one possible coalition is a1 a2. So this should be greater equals to v of a1 a2. Correct? So what does this boil down to in this case? X of a1 plus x of a2 should be greater equals to v of a1 a2, which is 100. This is equation number 3. Similarly, the next coalition may be a1 and a3. That should be greater equals to v of a1 a3. So that basically boils down to x of a1 plus x of a3 should be greater equals to 100, because v of a1 a3, as you can see, is 100. So this is my equation number 4. And finally, the coalition consisting of a2 and a3 should be greater equals to v of a2 a3. So x of a2 plus x of a3 should be greater equals to 0. So what we basically want to find out is that what will be the payoff vector that will satisfy all these 5 conditions. So how are we going to find that out? So let's go step by step. Firstly, let us say I consider equation number 2 and equation number 3. From these two, what can we conclude? If I just flip sides from equation 1, equation 2, what can we write? 150 is equals to x of a1 plus x of a2 plus x of a3. Okay. And from equation 3, what we can see? That this part is greater than equals to 100. So I can easily write this down as greater equals to 100 plus x a3. Right? Simply just substituting. So bring the 100 to the left. So 50 greater equals to x of a3, and that implies x of a3 should be less than equals to 50. Okay. So we get upper bound on x of a3. And from equation 1, as you can see, we have got a lower bound. That means it should be greater equals to 0. Right? Therefore, combining this with equation 1, what can we say? That x of a3 should lie between 0 and 50. That means just XA3 should belong from closed interval 0 to 50. Right? So in the exact same way we are going to do the rest. So now what we are going to do, we are going to take the condition for grand coalition, which is equation number 2, and I'm going to take the fourth equation, which is for the coalition A1, A3. Again in the same manner I'm going to write down x of A1 plus x of A2 plus x of A3. Now over here what do we have from equation number 4? X of A1 plus x of A3, x of A3 is greater than equals to 100. So this thing is greater equals to 100 plus XA2, and this will exactly result in the same thing. 50 greater equals to x of A2, and x of A2 is less than equals to 50. Fine. And again from equation 1 we have a lower bound for x of A2, which is again positive over here. So we are going to combine this result with equation 1. So combining with 1, what am I going to get? 0 less than equals to XA3 less than equals to 50. That means XA2 will belong to the same interval 0 to 50. And finally for the last one, taking the grand coalition equation 2 and equation 5. So what was equation 2? 150 equals to x of A1, x of A2, x of A3. So from equation 5 what do we see? X of A1 plus A2 should be greater equals to 0. So this is greater than equals to 0 plus XA1. So XA1 is less than equals to 150. And again we have from equation 1 a lower bound. So we'll just combine it. What do we get? 0 less than equals to XA1 less than equals to 150. So XA1 will belong to 0 to 150. Right? So we have got a range for all the possible payoffs. So now we can finally get to answer. So what is the core of this game? It is a set of all possible payoff vectors which belongs to the imputations such that these three conditions hold. The first component should belong to 0 to 150. The second component XA2 should belong to 0 to 50. And the third component XA3 should belong to 0 to 50. This is the final answer of core of this game. Okay, so thank you.